All right, and it's all yours, Jeff.
Thanks, Oliver. Good afternoon, everyone. As Oliver said, my name's Jeff or Jeffrey Jones. I'm the regional sales manager for the Southeast, covering Tennessee, Mississippi, Alabama, Georgia, North Carolina, South Carolina, Florida, and Puerto Rico. I've been with DENSO since 1993, working in different facets of our manufacturing facilities, and now 11 years in the robotics group. As Oliver said, we're going to be going over the how to create a simulation using our WINCAPS 3. The objective here that I want to get across to everybody is how easy it is to get in there and add that wow factor to impress either your customers or your management, doing this within under 20 minutes to create simulations. The simulation that I'll be creating today is similar to one that I have worked on with one of my customers, using an in-feed conveyor, then an outgoing conveyor, bringing tubes of hand lotion in, picking them up off of one conveyor, rotating the product 90 degrees, and placing it down on a indexing conveyor that puts the tube of hand lotion into a box. So the agenda is I'm going to go over what's required, then I'm going to step through a simulation, and then share some links and supporting documents, and as well as a link for the available webinars, which you may already be familiar with that link if you've signed up for these webinars. So what's required? First of all, you need to have our full license of our WINCAPS 3 software. When you purchase this, it is at list price, it is $1,055. It's a full version. It's a site license, and I will also supply you a link to where you can get the free updates. And we suggest that you go out frequently and check for any of the WINCAPS 3 updates. There are other versions. We have a light version of this software, and we also have a trial version. The trial version comes with each robot. It's a 30-day trial version, and then you can try it out. And if you want to buy the license, then you just purchase the license and then add it to the trial version software that you'd received from the robot. What I'm going to be doing is, as I mentioned, the simulation that we're going to be looking at, the robot that I'm going to be working with is one of our newer robots, the HSR 065. It's a 650 millimeter reach robot. And this particular version has a 200 millimeter Z-axis stroke. The robot is capable of an 8-kilogram payload. And as you see, an average cycle time, specified cycle time for this robot is 0.28 to 0.31 seconds. That's an industry standard cycle. So what I'm going to do is bring up my WINCAPS software. I already have the WINCAPS running. So I know what I want to do. I'm going to go into File. I'm going to go to New Project. I'm going to pop up a window to ask me if I want to retrieve information from the controller for creating my project, or do I want to select the robot type manually? I don't have my hardware. That's one of the nice things about the WINCAPS software. You can do all of your groundwork up front without having your hardware. You can confirm all your motion and your cycle time without having the necessary hardware, robot, and controller. I'm going to select my robot type. I'm going to give it a project name. I want to go in and I got to make sure that I'm under the right robot controller category, RC8. the robot type I'm going to select is the HSR, and then just the HSR 065 base model. Come in, and I know I want to use a 200 millimeter stroke Z-axis. Some of the options that you see, we're just going to kind of click through these. Not all these options apply to this this presentation or this webinar. Then you select the Ethernet IP address or your field bus communication that you want to communicate to the controller with using your PC, either Ethernet or RS-232. So, and then your variable sizes, I just generally just go to default, and these variable sizes can be adjusted accordingly as you get into programming. And then your I/O device assignment, this is where you would actually select your field bus device, how you are going to communicate, whether you're going to use just discrete I/O or PLC I/O or Ethernet IP I/O. I'm just going to leave it at mini I/O. Then before I finish, it's going to tell me what all the options are I selected. So then once I confirm everything, then I can click finish. It is loading the project up. Then there's a few more things that we can go through, these easy settings. And once again, these easy settings can be adjusted accordingly after the fact, after you get your project created and your simulation done. I know that my payload is less than a pound, so I'm going to adjust the total mass at 1,000 at 1 kilogram, and leave all the moments of inertia as they are. Then I want to adjust the motion optimization to mode 3, and what this does is optimizes the motion for each one of the commands that I give it for a linear move or a point-to-point move. And then just complete. Once I'm completed, I want to go back and make sure I save anything that I've done. So now I'm ready to go ahead and create some simple code. So I go to Project, Add Program, name the program, Pro 1, click OK, and it creates the program window for me. In order to start programming, I'm going to be programming just 2 simple points. I'm going to be using two position variables, P2 and P3, and we'll populate the coordinate data into these positions in a little bit. So what I want to do is go ahead and start writing 2 lines of code. So I write 1 line, and what I want to do is duplicate that so I can drag across it. It's just like any other Word document or whatever. You can drag across it, copy it, I can paste it, and then go in and adjust the position variable. This is all the code I'm going to write to do a simple pick and place from one conveyor to the next. But we will be building on this program a little bit too as I go on to show you the first part of the simulation. So then now I got my code. What I want to do is go over to the ARM view window. And when you click on the ARM view window, it's going to bring up a separate window to show the robot model that you have selected. And in this window, I can move the robot around by just clicking on the left mouse button, and I can move it up and down, rotate it. I can position it differently. I can zoom it in or out. But then if you come over, now I'm ready to teach some points now. come over to the left-hand side of the screen to the arm operation. You have operation mode, you have joint, which I can move each individual joint. And then the T-axis. Then XY, it's a coordinated motion of each axis, maintaining the tool posture. And another way to move the robot around is you can come over and drag on the arrows to move it into a relative position where you may want to teach it. What I need to do is I need to teach a couple points. I'm going to, looking at the base of the robot, the center line of the robot, that is our work coordinates off of 0, 0. So my incoming conveyor is going to be to the right of the robot, and my outgoing is going to be to the left of the center of the robot. So I want to move my x-axis back a little bit and then drag my y over to a position to where I can pick it up and then bring z down and set that position. Once I have the robot at a position where I think is relative to where I'm going to be, then what I want to do is my pick position is going to be position 2, or p variable 2. I highlight the p variable 2, I get to position, it's going to read the current, the position data here, and then once you okay it, it writes it into that position variable. So now I need to do the same thing with my pickup or my place position. And place it somewhere in there and do the same thing, repeat, highlight my position 3, p variable 3, get the position, and then record it. Now I have position data stored in both of these, the P2 and P3, and now what I can actually do is I can go ahead and run this code. In doing so, I have to prepare the program so it can run, and then press the play button, and then just do a continuous run of it. And of course, it's only running at 10% speed. I can speed that up. And you can kind of see the motion of path. It's just going from P2 to P3, and you can see it's in an arc motion, mainly because I'm doing a point to point, and it's trying to get to from one point to the other in the fastest path that it can go. Of course, my pick and place motion is not going to look like this when I'm done with it. I can't move on a horizontal plane from one point to another to pick apart and place it. So what I'm going to do is I'm going to stop my program, reset it, and then what I'm going to do is go in and add some code to what we call an approach. I'm going to add an approach move. And what the approach does is allows the robot to move over the target position at a defined height. I'm going to tell it to move over P2 at 100 millimeters above it. So once again, what I can do is I can take this line of code And I'll need to do the same for the place position as well. Copy it, paste it above my move, go in and change my target position to match my actual target position. So now I'm able to approach over each move or each position by 100 millimeters. And then once I get above it, then it's going to move down to P2. But there again, I don't want the robot to move on a horizontal plane back over to the approach. I want to be able to bring my Z-axis up and clear any obstructions that might be in the way. So I'm going to use a command that we call depart. And the depart is actually relative to its current position. It doesn't have anything to do with the target position, but the relative position that it was at. And I'm just going to depart the same height, the same target height. Again, I can go in and I can copy it, paste it under my move, and now I have a code that is going to resemble a true pick and place motion. Of course, I want to, just to verify there's no syntax errors, I can come up here and I can check my program. And of course, I do have 4 errors. So what I have done is left out a couple colons or commas, I mean. And that took care of my errors. I have no errors, so I should go back up and save my program. Bring up my arm view window and prepare the program to run. You can see that I'm not just moving on a horizontal plane. It's actually approaching over my target positions at 100 millimeter, moving down to the target position, and departing 100 millimeters from that relative position that it was at. Now, to simulate this a little more accurate, I don't have the robot would have an end of arm tooling on it, and a gripper, possibly either a pneumatic or a servo gripper. And in order to simulate that, what I need to do is, for the timing, to get a true cycle time, I can go in, and after it moves down to each target position, put some delay there, so it simulates or emulates the gripper opening or closing, looking at the switches, your open and close confirmation switches. So we just put in a command. It's called delay, and I'll put 200 milliseconds. That may be a little long. You can adjust that. Once again, I want to check my program. No errors. Save it, and then prepare it to run. You can see it has a little bit of a lag now as it gets down to each target position before it departs up away from that position. So since I'm running, I want to be able to have an idea what my cycle time is. If you go down to the bottom left-hand corner under program list and click on the program list tab, you see I have Pro 1 running, and then the current cycle time that it is running from P2 to P3 is 1.53 seconds. This is one way to accurately, judge what the cycle time is going to be, and it is fairly accurate. Okay, so now I've got my motion in my code written. I want to make this look more like my actual application is going to be. There's tools that we can use in our model tree that we can take and lay in objects to emulate a conveyor or the product on a conveyor. We can lay them around the work coordinates of the robot and also attach them to the tool end. What I'm going to do is add some objects to make it look like two conveyors in there. The incoming conveyor will have a incoming part, and the outgoing conveyor will have a part. And then I'll actually add a part to the end of the arm tool just to show you that the orientation is picking it up, and then the T-axis is rotating 90 degrees to place it down on the place conveyor. So first thing I want to do is make sure I'm under my robot node. I'm going to place the incoming conveyor first. And all of your objects, when you bring them in, they're going to be green. And you do have the option, after you select that object that's been brought into your screen, you do have the option of changing the color. So what I'm going to do is, just to define the color a little bit, is change the incoming conveyor to orange. I'm going to change the relative position. Yep. You drag this down, and so you can see the relative position and the scale as well, the size. But I'm going to change the relative position on the x-axis to 0, the y-axis to 500, and then the z will be 0. Now I need to size that conveyor so it looks like a conveyor. So I'm going to size the X to 50, size the Y to 400, and then the Z I'm going to leave at 100. So there I have an incoming conveyor, similar to an incoming conveyor. Yeah. So now I want to go in and add my outgoing conveyor. So I'm going to select the cube again. And I think it's hidden. I think it hid it behind my other conveyor. Nope. Okay, so now I'll select the cube. Change that's the outgoing conveyor. I'll change the color. Well, maybe. Okay, there we go. Change the color of the outgoing conveyor. Now set the relative position for the outgoing conveyor. The x-axis is going to be 200. The y-axis, I'm going to set it at a negative 400 to bring it on the other side of the robot arm, and then leave it at Z. Leave the Z at 0, and then again scale the outgoing conveyor is going to be in the y x-axis is going to be 150 millimeters. And then in the Y is going to be 400. And then the Z is going to maintain at 100. So you can see the two different conveyors. I've got part coming in this conveyor, and I'm going to rotate it 90 and put it on the outgoing conveyor. Now, what I want to do is place a part on my incoming conveyor in the orientation that it's going to be coming in. Select my robot node and then the part. And I want to change the part color so everything doesn't just run together. And then now I need to change the I'm going to change the size of the part. 50 in the X, 100 in the Y, and then 50 in the Z. Now I'm going to put it on the place it onto the conveyor. Change the relative position of it to the conveyor. To the X coordinate to 0. The Y coordinate to 368. And then the Z to 75. And I need to adjust this. I'm supposed to be 50 on the there. So now I have my part sitting on the incoming conveyor. I want to do the same thing to my outgoing conveyor. I'm going to place a part, select my robot node, select my cube. There again, I want to change the color. And then size it is going to be 50 in the X. Also, it's going to be 100 in the Y and 50 in the Z. So the parts look similar. Now I want to change the relative position to put it on the outgoing conveyor. It's going to be 200 in the X. It's going to be a negative 250 in the Y. And then 75 in the Z. But now what I got to do is take into account I need to turn that part 90 degrees. So I'm going to go down to my RZ. I'm going to rotate my RZ by 90 degrees and bring it around. So now I have my pick and my place positions. Now I need to go in and put a product on top or on my T-axis or my end of tool. I'm going to come over to my model tree under tool and go to tool 0. And then I'm going to add a cube. And then I want to change, there again, change the color. Change it to black just to stand out. Now, I need to adjust my size of the tool product. And there again, it's going to be the same size as that's on the incoming and the outgoing conveyor. It's going to be 50 by 100 by 50. Now I need to place that on the end of the tool. In my end of the tool, the reference on the end of the tool is actually 0, 0, 0. So I'm just going to adjust X, Y, and Z to 0. Which brings it to the end of the arm. So now I'm going to have to go back and reteach my position 2 and 3 again. So we kind of zoom it in here a little bit. Go back to arm operation, and then I'll drag the robot over. I can get it close, and then I'll use the slider switches to get it, you know, a little more. I'll come over, change it to I'll leave it in XY. Slow it down a little bit so I can get a little more refined position. I want to rotate. Get it to lay on top. Okay, so it's close to being lined up there. I'll bring the Z down on top of the conveyor. And then I want to come back down to my position 2 variable, get the position. And then I want to do the same thing for the place position. So the place position is close. Record the P3 position and OK. So now I should be able to run my simulation with these objects laid into the simulation just to kind of get a feel for what it's doing. Of course, it's only running 10% right now. We'll open that up. And at 10%, it's 10-second cycle time. Bring it down to, I'll set it up at 100. And that is how you create a simple simulation. You also have the capability, instead of using the model tree, the objects that's in the model tree, we also have the capability of bringing VRML files and DirectX files into your simulation layout. Another neat thing is if you need to, maybe you're in with a customer going through the simulation, and your customer doesn't have WINCAPS, but they want to be able to show their management a video of this simulation running. We do have over on the right-hand side, you can go in and do a recording of the simulation, record it, and what it does, it stores it in a AVI file. I'll save it. What I'll do is I'll go back and let me stop the I need to the AVI file will be stored in your folder to where your project is stored. So you can go in and copy that AVI file out and send it to your customer so they can share with their chain of command or their management as well. But that's pretty much it. That's how to create a basic simulation, how easy it is, and to even add objects in and around the work coordinate of your robot as well as your tool coordinate. So I will bring the PowerPoint presentation back up. And here are some links that I would be sending out at the end of the seminar once I get the attendee list. We have a link out on YouTube on how to go through and create a simulation. This video is more in depth, more detailed. We also have a document that is made available, a step-by-step document on how to create a simulation. There's also a YouTube video link that once you have your simulation created, if you want to improve it somehow, like the motion or what the cycle time, this video will step through it with you. Also, as I mentioned at the beginning, the WINCAPS 3 software, it's important to keep your software updated. As I said, the updates are free. This link here will get you to where those updates are. And the link here is a link to the most recent schedule of the webinars that we're offering, as well as these seminars that are upcoming in this next week. At this time, I want to thank everybody. I'll turn this over to Oliver if we want to review any of the questions.
All right, thanks a lot, Jeff. Great presentation. I will go ahead and go through the questions now. If you guys still have any questions, go ahead and post it on the right side in the Q&A section. Let me see here. We'll go to the first one. So Stephen asked, oh, that's weather. We're talking about the weather. Stephen asked, if you leave the @P out of the move line, is it like an @E? It's going to act more like an @0 instead of an @E. The @E is the encoder check, and encoder checks take a slightly longer for cycle times, and it'll stop at the to make sure that it's at the exact position that you programmed, whereas an @0 is slightly faster. It does go to that point, but I don't know, is there a slight radius on there because it's an @0 and not an @E?
Yeah. It is. It tries to get as close to that target position as possible. It's not as aggressive as an arc as an @E is.
Okay. All right, and the next question was from Mark. Can the video be exported? And yes, it can. It can be exported, right, Jeff?
Well, it's saved in an AVI file.
Yeah.
So yeah, it can be. There again, it's saved in the project folder, the main project folder under an AVI file, and that can be copied and emailed out. So yes.
Okay. And his next question was, can the frame rate be increased to run smoother? I stated that on the webinar right now, it's a little bit choppy because it's on WebEx. We do have some options in there in our software to make it run a lot smoother, and it is really smooth actually when you look at it on your own computer.
Exactly.
And I don't know about the video frame rate when exporting to an AVI file. I don't know if we have those type of options or not.
I don't think there is, but the AVI file is pretty smooth as well.
Okay. Yeah, so it's fairly smooth. It just looks choppy on the WebEx. Just to answer your question. Mark also asked, can the images be brought into the video? Yes, I understand they will be flat, not 3D. I asked if you can elaborate. I'm not sure what you mean by other objects into the video.
I see that as importing the CAD files via VRML or DirectX, and yes, they would show up in the video. That's once they're in your simulation in the ARM view window, it would actually show up in your video as well.
Okay. Stephen asked, is this a way to draw the end effector? And I said, yes, adding an object to the to simulate a gripper is a way to show an end of arm tool.
But if you have a VRML file or a DirectX file of your end of arm tooling, you can bring it in and put it on the end of arm. The only thing is you won't have the motion. You won't see the motion like the gripper opening or closing.
See, Stephen also asked, is the approach and depart on the Z-axis of the approach and depart commands? I said that yes, the approach and depart is only for the Z-axis. It follows sort of the it's parallel to the end of arm tool.
The tool, yeah, the tool.
Yeah, so yes, those are only for the Z-axis. So I believe it's true, right, Jeff?
Yes.
Okay. Herlacio asks, oh, it's in Spanish. Sorry, I don't know Spanish. I'm sorry. I don't know if let me try to copy and paste this in Google Translate. Give me 1 second here. Translate. Sorry. Could you share the video for me, please, later? Is what he asked. Yes, we will email everyone the webinar link. So he asked if we can send a video, and we're going to email everyone afterwards with the PowerPoint presentation as well as the link to the video of this webinar that we're recording.
Yeah, along with all the other support links as well.
Yes. Where else? Sorry, my mouse is away. CAD files would probably work. Yes. We have a 3D or 2D CAD. Can you import 3D or 2D CAD? I believe it's, what can we import, Jeff?
I'm not a CAD man. That would have to come from Dave.
Got it. I'm not 100% sure, but I believe we can import the 3D file because we can put in the robot and simulate it going in and out of like
right. Yeah.
What's it called? Like a chuck and like a machine, pretty much.
Yeah, exactly.
Okay. So yeah, I believe the 3D files are able to be imported. Is it possible to transfer to the software and set your positions? Possible to transfer to the software and set positions? I'm not 100% sure. I think you're asking if we're able to set the positions out or transfer the program positions if from the robot. So maybe if you're programming on the robot, can you transfer to the software? Oh, go ahead.
I'm wondering if he's wanting to know if, If you have a CAD drawing and you know where your pick position is, can you just import that, I guess, into the WINCAPS? I'm not sure what.
Yeah, maybe. Alejandro, if you could elaborate on your question, we'll get back to it. Oh, here, similar to tooling simulation, can we import a full and work with it?
It might be best if we get Carlos and get these questions to Carlos from them.
Okay. Of course. Import a file and work with it. So can you, similar to tooling, can we import a file and work with it? Yes, you can import the CAD files and work with them, but you can't. It's not. I don't think it's going to give you positions. If you import a CAD file, we're not going to know the position of all the openings and things like that. It's more of a visual, right, Jeff?
Yeah.
Yeah, so if we import CAD, it's not going to have the dimensions and things like that. It's just more of a visual to have your robot go in and out of the machine, or put the gripper on the end of arm tool, etc. But again, we'll go back over this and email everyone with the PowerPoint as well as the link to the video. And then if you have any more questions, just email us back and we'll give you a call or send you an email answering your question. So if we didn't do that today. So sorry about that. But I think that is it. We will stop this recording. So thank you, Jeff, and great job today. Thank you everyone for joining. And we have more webinars next week, I believe. So stay tuned for that and go ahead and register for those as well. So thank you guys. Thanks, Jeff.
Thank you.